Matrix. Welcome to Mindset Learn, the home of the brain. You tuned in this hour with myself, Deborah Precious, and your favorite physics teacher, Tracy. How are you?
Good, and you?
Fantastic. Now, could you
Good.
quickly let our Matrix know what you're touching on today?
Well, today we're doing chemical industries, guys. We're doing the fertilizer industry. Basically, we're going to look at the three most important chemical industries, and we're going to go from there. This is one of those sections, I promise you are going to get a question on this. So, and this is learn work. This is straightforward, learn. Yeah.
Great, you guys. I know this is a very important time for you, Matrix, so it's good to just download the notes that we posted on you online, follow through the work with us, and just stay in touch and connected. If there's anything you feel you don't understand, facebook.com/learnextra, or at our Twitter handle, which is @learnextra with an X, is where you can get in touch with us and contact us. Now, I'm sure you all have been aware of the Get Connected competition. If not, listen up. You get to stand yourself a chance of winning yourself a great Sony Xperia L cell phone, together with airtime vouchers brought to you by Vodacom. Now, all you have to do is enter the competition via Curio. You go onto Curio, the code is LEARN. Now, once you're on Curio, you select your favorite teacher, for example, Tracy.
Me.
And then, once you've done that, you submit, and then you move on back to our Facebook page, and then you like your favorite teacher's graphic via the link that we provided to you on our Facebook page, and then that's how you enter. Then once you're done liking it, don't forget to share it to get as many friends as possible to like the exact same picture. Now, the people with the most likes get the opportunity of winning themselves a great Sony Xperia L or Vodacom airtime. And what's amazing, guys, 2 has been given away already. 2 Xperias have been given away. So there's only 2 left. So make sure that you at least get yourself, counted among the winners. Just try. Push for likes, guys. I believe in you. Tracy, over to you.
Me.
Okay, vote for her. That's,
Sorry, I've been told I'm allowed to push for votes. I like competitions. I like winning competitions. Just saying. But even better, you guys get a really nice phone. It's a smartphone. Hey, they are smartphones.
It's amazing.
And airtime bonus. Okay. Ooh, look. As you can see, even the board's excited for me. It's doing its own thing as per usual. So, guys, we're going to go into the chemical industries. Like I said when we started, this really is just learn work. So this is stuff you need to learn it. You need to find a way to make sure you know the equations, you know the conditions, and that sort of thing, because as you're going to see when we do the questions, it's really just learn work. They can't trick you in this section, which is actually so nice. So what we're going to try to get through today is we're going to discuss the contact process, the HaberBosch process, the Ozwald process, the 3 most important ones. We're going to look a little bit at how fertilizers are made, where we get them from, and then, of course, discuss the impact and use of fertilizers. You are going to get something about that very special word with an E called eutrophication. I promise you, somewhere along the line, they're going to ask you about eutrophication, which, of course, you've done since grade 10. All right, so let's start with the challenge question. Okay, and the challenge question is, which one of the reactions below occurs when the fertilizer ammonium nitrate is prepared from nitric acid? So I'm going to make ammonium nitrate from nitric acid, and I want to know, is it a decomposition reaction? Is it an oxidation reaction? Is it an acid-base reaction? Or is it, a dehydration reaction? Let's just pretend that there isn't some very funny word over there. Okay, it's a dehydration reaction. Who knows what I put in there? Let's just ignore that it was there. Anyway, so which one of the reactions is it? Ammonium from nitric acid, ammonium nitrate, is decomposition, oxidation, acid-base, or dehydration? Okay, now you can't just go and put on the page, you can't just go A, B, C, D, all right? I want to know why. Okay, so I want to know why you think it's that type of reaction. So there must be a reason behind it. So it's not just enough to select one. I want to know why you think it's that one. Okay, so we got that. Ammonium nitrate from nitric acid. All right, so let's go onto the production of sulfuric acid, which is the contact process. Grade 12, this is a very important process for us as a country. We're one of the largest exporters of sulfuric acid in the world. And I read, and I can't I don't understand why, but apparently in terms of industrial wealth, that actually means we're quite industrially wealthy. I do not understand that. It's just like the whole aluminium thing. This is why I'm a science teacher, okay? I don't get the economics of these things. But remember, sulfuric acid is an incredibly important industrial chemical because we use it in a bunch of things. Besides making sulfates to make fertilizers, we use it as a dehydrating agent. Remember, it's one of the things we use in organic chemistry as a catalyst as well. So it's really important. Now, the contact process is a 4-step process, okay? Step 1, we take sulfur, we oxidize it with oxygen, so we burn it to oxygen and we get dioxide. That sulfur can come from pure mining, from ore, or sometimes it comes out of the coal that we burn. Okay, so we can get that. Then that sulfur dioxide is now taken, and this is actually where the contact process gets its name from, is we now oxidize the SO2, which is the catalytic oxidation of SO2. It's catalytic because we have to use vanadium pentoxide as a catalyst, and it's a very nice catalyst, and it's easy for us to get because we have vanadium mines. I would tell you where, but my geography is bad, so I just know it's in the north of the country somewhere. And I don't know if it's the northern province or Limpopo. So don't ask me because we know I don't know. All right, but we use vanadium pentoxide as a catalyst. The thing here, though, is that this is a reversible reaction, which means equilibrium principles need to be applied. And remember, in industry, we want to make money. It's not about just producing a product just because we can. If we lose money when we produce it, that's stupid. So we want to make money. So we've got to make sure we can get the most product in the shortest amount of time at the smallest cost. Okay? So now, the production of SO3 is actually an exothermic reaction. So because it's exothermic, when we consider the temperature, ideal conditions say to us that the temperature must be as low as possible to favor the forward reaction, because then it favors the exothermic reaction. However, rate of reaction tell us that if we make the temperature too low, then the reaction happens too slowly, and that doesn't help us either because time is money. So we make a compromise, and that is that it occurs at about 450 degrees Celsius, which in industry terms is a relatively low temperature, though it's not a temperature I'd want anywhere near me. Okay, second thing is pressure. And if we look at this reaction, we have 3 moles of gas on the left-hand side, 2 on the right-hand side. So if we have a high pressure, we will get a high yield, but making pressure chambers for these reactions to happen in is actually very, very expensive. Okay, so we've got to be careful about cost. And in fact, this reaction happens at a really nice rate at 1 atmosphere, which is actually a very low pressure, but it works very, very nicely. And then, of course, it's a case of, well, if we keep adding in reactants and taking out the product, we'll increase the rate. Okay, so it's a fairly simple process. From here, though, this is where life gets interesting, because we take that SO3, and now, yes, we can put it straight into water, but that forms sulfurous acid, which is actually quite a dangerous acid. It's very exothermic. That sulfurous acid is a problem because that sulfurous acid boils quite quickly. We don't want sulfurous acid. We want sulfuric acid. So here life gets fun, because actually I take the SO3 and I react it with H2SO4. And that forms an acid called oleum. Okay, oleum, not a W, that's a U. Okay, let's pretend I can spell. All right. That forms oleum. And now right now you're going, hang on, wait, Tracy. What do you mean we have to put sulfuric acid in when I'm trying to make it? Well, this is where it's good, because if I take that oleum, react it with water, I get 2 moles of sulfuric acid out at the end. So for every 1 mole of sulfuric acid I put in, I get 2 out. So I double the amount of sulfuric acid I have. That's a good thing, okay? Simple process, okay? Now, why do we need it? Well, sulfuric acid is a drying agent. It's hygroscopic. It absorbs water. It's electrolytes in batteries, which is why car batteries are so dangerous. Recovery of metals, such as uranium and copper, very important. We use it to clean metal surfaces. It produces fertilizers. When we make sulfate salts from it, from the SO4, we get things like ammonium sulfate, potassium sulfate, good sources of nitrogen and potassium for plants. Okay. But the ammonium that we've been talking about doesn't just drop out of the sky. First thing we need to look at with ammonia is the HARBOR process. Now, we are very blessed as a country in that we are one of the few countries in the world that has the license to create ammonia using this process. It was patented in Germany. It's actually known as the HaberBosch process. Haber is the man who came up with the chemical process of it, and Bosch is the one who designed the actual industrial way of producing ammonia, and we have license to use it, okay? So that's a good thing. We're not complaining about that. And it's the simplest equation on the planet, which you have seen lots and lots and lots, and it is the simplest process in that it's simply nitrogen plus hydrogen gives me ammonia. But we will use a catalyst, iron oxide, okay, or iron, just plain iron. And it is an exothermic reaction. Once again, it is a reaction that has equilibrium properties. So that means we now need to consider the equilibrium. And I'm just going to double check my temperatures because, you know. Anyway, your temperature, once again, exothermic reaction, which means if I make the temperature low, I favor the forward reaction. However, the reaction goes quite slowly then. That is a problem because if it goes too slowly, we get too little. So we compromise as well, once again, and the temperature is around 600 to 800 Kelvin, which means it's between 400 and 600 or thereabouts degrees Celsius, okay? Depending on how fast we want it to go. When it comes to the pressure, this one's different to the sulfuric acid. 4 moles on this side, 2 moles on that side. However, the forward reaction isn't favored as much by a low pressure. So because we've got so few moles on the right-hand side, we want to favor that. So we increase the pressure. And in fact, the pressure for this, is 350 atmospheres. Okay, that is an incredibly high pressure, incredibly dangerous, incredibly expensive. Okay, but it gives us a nice yield. Concentration. This we actually manipulate in 2 ways. Number one, we keep putting in nitrogen and hydrogen. If we keep putting in reactants, the reaction keeps going. The ammonia gets taken out by putting it into water. Okay, so we actually take the ammonia gas out, so we decrease the concentration of the products. By decreasing the concentration of the products, we favor the forward reaction, which means we make more ammonia, okay, which is what we want. Why do we want it? Well, ammonia is a very good cleaning agent. We use it for fertilizers to make ammonium salts. We use it to make ammonium carbonate, which is used in the textile industry. And then, of course, we need it for nitric acid, okay? Now, the manufacture of nitric acid brings us to our third process, which is the Ozwald process. And once again, the Ozwald process has 3 steps, okay? The first one is actually known as the catalytic oxidation of ammonia, okay? It's catalytic oxidation because we actually do need a catalyst, all right? Don't need to worry too much about what that catalyst is, but we do need to use a catalyst, and it's a one-way reaction, so the ammonia gets catalyzed with the oxygen. We end up with nitrogen monoxide. That doesn't help us much. We then take that nitrogen monoxide, we burn it or react it with oxygen. That forms nitrogen dioxide, and that nitrogen dioxide can then be put into water with a little bit of oxygen, and we get ammonia. What am I talking about? Nitric acid, ammonia, that was before. So this is a 3-step process. So we cannot go straight from ammonia to nitric acid. There's no way that can be possible. Is in 3 steps, okay? No equilibrium systems in here, so we don't need to stress too much about those. Oh, no, didn't want that. Now, why are they important? Well, your nitrate salts. Now, nitrate salts come when I mix nitric acid with another substance, okay? So that nitric acid, the NO3 is a nitrate, okay? They're very, very soluble in water, which then allows our plants to absorb nitrogen, which is important. Remember, plants cannot absorb nitrogen from the air, despite the fact that our air is 78% nitrogen. Okay, why do we need to do the chemical industry? Well, there's lots of challenges which they're going to ask you about. Things like safety issues, okay, which is regarding the transport of the chemicals. We know there's often accidents on our roads, unfortunately, chemical spills, all of that sort of thing. Pollution, all right? If you've been around, and you guys, definitely for you guys, in terms of your school career, you've heard nothing about but global warming, pollution, the hole in the ozone, the whole thing, so that's also an issue. Waste disposal. Big problem for a lot of countries is where do we get rid of our waste so that it doesn't go into our groundwater, so it doesn't destroy our plants and our animals. And then, of course, there's energy consumption, which for us as a country is a big concern. We've probably all at some stage had to deal with some load shedding. So if we now have our chemical industries sucking all our energy, which we need to make more money, it becomes a bit of a catch-22 situation, okay? Now, the fertilizer industry is based on the fact that plants have 3 primary nutrients: nitrogen, potassium, and phosphorus, okay, which are then put into our fertilizers. I'm not going to worry about too much about the NPK numbers, all right, but things like potassium, we used to get it as, used to be mined in a thing called potash, okay, it's becoming more and more scarce. Things like phosphorus, actually this is the cutest thing, it's not really cute, it's a bit gross, but it's alright. Phosphorus used to, a lot of it came from something called bone meal, and it's exactly what it sounds like. It's finely crushed, dried animal bones. Now, until World War I, animals died at a fast enough rate, okay, so cows, horses, whatever, okay, died at a fast enough rate for us to be able to take those bones, grind them up, use them as fertilizers. Then the population exploded. And now they're just not dying fast enough for us so we can dry them out, okay, which is a bit gross, but sorry, that's the way it is. So we got to find other ways of doing it, which is calcium phosphate, okay. And then lastly, I actually got through all of this, I'm quite impressed. Eutrophication, and I've gone very, very quickly. Remember guys, eutrophication happens because there's extra nutrients, the nitrates, the phosphates, etc. in the water supply. That causes an algae bloom, okay, so now we get this horrible green algae on top of our water. That's not actually the issue. The issue becomes when the algae dies. The algae dies, and the bacteria that's needed to decompose the algae uses up the oxygen in the water. So it removes oxygen from the water. When the oxygen gets removed from the water, that means the fish die, the marine life dies, and the water plants die. So that's an issue. And then people drink that water, and there becomes lots of other human health issues as well with that. And on that wonderfully exciting note, I think it's time for a break, and then we'll do some questions.
Yes, it is now time for a quick break, you guys. It's an opportunity for you to freshen up after that really cool, quick lecture, as well as tackle the challenge question. We'll see you guys in a few minutes. Welcome back, Matrix. I hope you're all good, done the challenge question already. If you're not, you still have another break to get on it, but for now you have to concentrate. And do not forget, once more, to enter our Test Yourself competition, which is on our Curio page. You just answer the questions, and you could stand yourself a chance of winning this beautiful Casio calculator, which is very useful, especially in your year. And another thing, it's not just about winning the calculator, it's also great revision and practice. So, let's carry on with the lesson. Tracy,
Great.
over to you.
Thank you. Yes, the Test Yourself questions, guys, are always based on what we do, so they're actually quite important. All right, so let's hop right into these questions, and we've chosen them specifically because a lot of them have flow diagrams. Remember, with flow diagrams, just as with the organic, I can ask you a lot of stuff in the flow diagrams, okay? So this one is adapted from the February-March paper in 2009. It says about 1/3 of the protein by humans, for humans, comes from fertilizers. The flow diagram below, that actually makes no sense, but anyway, it doesn't actually matter. The flow diagram below shows 3 industrial processes, A, B, and C, that result in the production of fertilizers. Guys, as soon as they mention industrial processes. That means they're using Contact, Haber, and Ozwald, which means you need to be able to identify them. Now, before we even go to the question, I'm not even going to look at what question 1 says. I'm going to look at my diagram, and I'm going to go, okay, let's just talk about what's missing. Okay, and we're going to go, okay, there's a whole bunch of stuff missing. Let's try and fill it in because they've named stuff, they've left stuff out on the diagram, there's X's and all sorts of things. Spend the time working through the diagram before you answer the questions, okay? So we look at process A, and process A goes to making nitrogen into gas, okay? Now, I just said to you it'd probably be Ozwald, Haber, or Ozwald, or Contact, but making nitrogen is not that. I didn't actually mention it earlier. Nitrogen comes from the fractional distillation of liquid air. Fractional distillation, okay? That is still a industrial process, and basically what that means is we take the air that we breathe, they put it under high pressure, low temperature, make it into a liquid, and then slowly heat it up. Nitrogen boils or becomes a gas at about minus 196 degrees Celsius. It's one of the first gases to come off, which means if they keep it at about minus 195, the nitrogen gas slowly comes off and everything else stays in liquid form. Okay, so it's the way we get the nitrogen from. Nitrogen plus hydrogen, that means we're now creating ammonia. That's the Haber process. Okay. Ammonia to sulfuric acid. Oh, no, that's not what they're saying. They're going, the ammonia gets added to sulfuric acid. That means I'm actually going to make ammonium sulfate. Okay. Because the ammonia reacts with the sulfuric acid and we get ammonium sulfate. Then over here, process C. Oh, look, they even name it for us. The Contact process. Yay, bonus. Sulfur plus oxygen gives me SO2. Now, we've just done step 2. So we're going to write it in, which is the SO2 plus the O2, which then gives me SO3. Then we've got SO3 plus H2SO4 gives me unknown, that's the oleum, which means that is H2S2O7, which we then add to the water and get to the H2SO4, okay? So now we look and we go, well, actually, if you were studying from this, this would be a nice mind map to study from. Okay, lots of things from here. In fact, if I was going to do this as a mind map to study from, I would just add in one extra thing is to take the nitric acid across and do the Ozwald process to find nitric acid, okay? Do the ammonia. First question, write down the name of process A. Oh, look, we just did that. Fractional distillation of liquid air, okay? We'll pretend you guys can read that, okay? Fractional distillation of liquid air. So we're done process A, done. Write down the balanced equation for the reaction which takes place in process B. Now they want the reaction for nitrogen, hydrogen gives me ammonia. So this one means we're going to have to write it down balanced. So first thing is we know it's nitrogen plus hydrogen, reversible reaction. Okay, gives me ammonia, and then of course we need to be able to balance it. So it's N2 plus 3H2 goes to 2NH3. We're nice and simple. Then it says write down the balanced equation for step 2 of process C. So we go back here and look what we did. Look, see, got it. Don't even have to think twice at the moment. So this is the point, is that over here, okay, we now have the SO2 plus the O2, okay, which then gives me, I'm going to write down all sorts of weird and wonderful things there, which is not true, okay, because it doesn't give me anything as to where I was going. So SO2 plus O2 gives me SO3. The most important thing that you're going to forget in this one is the fact that we need vanadium pentoxide. Okay,
Tracy,
Yes, sweet.
while you're on there,
Yes.
just a quick question from Sanele Mabaso. He'd
Yes.
like to know, what happens if you put SO3 gas in water?
So if I take the SO3, okay. Well, Zanele, if I take the SO3, and I'm just going to write it at the bottom, so we'll extend the page a little bit down the bottom. The problem is if I take the SO3 and put it straight into water, and this is quite important. So I take the SO3 and I put it into water. First of all, it's quite dangerous. We get all sorts of, it's very hot. But then I end up with this. I end up with sulfurous acid. Okay, so I end up with H2SO3, which is not what I wanted. I wanted H2SO4. So this doesn't have enough. So this gives me sulfurous acid. And in fact, sulfurous acid is the acid that happens with acid rain. Okay, because sulfur dioxide, that's SO2, not SO3. Look at that. I'm hoping somebody was screaming at the TV there and going, all right, so the SO2, no, it is SO3. Should I just actually shut up now? All right, I'm about to get, if I don't come back next year, you know why? Because I fight with the TV, I talk nonsense, but we get sulfurous acid, which is a problem for us. Okay, so next thing. Hope that helped. Nan says, write down the formula and the name of the product X in process C. So we look and go, well, I actually wrote it down. It's H2S2O7. Okay, H2S2O7. And it's oleum. Okay, or, once again, I'm trying to spell it with a W. Oleum. Okay, I have no idea where they get these names from. I'm just saying. Or we can call it pyrosulfuric acid. Okay, and it's also sometimes known as fuming sulfuric acid, okay? Hopefully we're okay. Then it says write the formula and the name of the fertilizer represented by Y. Now, I've told you already that it's ammonium sulfate, and I promise you, that should be a 2 there. Some of you are going, okay, I don't know why it's ammonium sulfate. Let me show you. So we're going to go back down here, okay? Let's take this off. Okie dokie. I just did it so I can wipe the board. And it's very important to make sounds when you do this. Okay, so we're taking ammonia, NH3, and we're adding it to sulfuric acid, okay? This is an acid-base reaction, okay? And what you learned in acids and bases is that we're going to give the hydrogen away, okay? And normally what would happen is if that base was attached to a metal, the metal would attach itself to the anion of the acid, okay? So we would get a salt that was some sort of sulfate and water, okay? But there's no metal attached to the ammonia. So what happens is this ammonia becomes NH4 plus because it's gained a hydrogen. The sulfate, and it would give both away, becomes SO42 minus. And these two are now attracted to each other. So that ends up giving us the salt ammonium, and I need two of them because it has a charge of +1, ammonium sulfate. Okay, so it's an acid-base reaction, and it gives me ammonium sulfate. So back here, they wanted the formula, NH4 2SO4, and its name, ammonium. Okay, the A turns into an A into a UM, and it's ammonium sulfate. Okay, then, and these are the type of questions where you sort of go, are they really asking me that question? And the answer is yes. Okay, so think carefully about your answers, because these are questions where you can either get them horribly wrong because you write nonsense, or you can get easy marks for them, okay? And it says, fertilizer prices increased by more than 200% in 2007. This rise is fueled by new demand. the population is exploding. So the first thing is give 2 reasons why there is a continuous demand for fertilizers. Well, food has to be grown continuously. The population is getting bigger. As our population grows, the food demand grows, okay? Also, even if you go and look at things like, and this is a bit of a contentious issue, is things like biofuels. Farmers are growing crops for biofuels. They need fertilizers to get the crops to grow faster, okay? Another reason why there's a continuous demand is because we continuously using our soil, and we don't rotate crops anymore, and we don't allow fields not to lie fallow, in other words, not to have any crops in them anymore, the soil that we're using cannot replenish the nutrients, so they can't get enough nutrients anymore. So we have to help them because we're actually overusing our soil. Then why is there an increase in the price of fertilizers? Straight supply and demand, okay? Huge supply, huge demand. People are going to make it. They're going to pay the price, okay? Plus, remember, the industrial processes needed to make the fertilizers get more expensive. The chemicals needed to make the fertilizers become more expensive. The cost of fuel, think about in our own country, just how our fuel price is, all right, and how it goes up and down all the time. The recent downward trend was brilliant, okay? But if we increase the cost of fuel, then it increases the cost of driving the trucks to get the fertilizers to farmers. So all of that increases the price of the fertilizers, okay? This is very much an opinion-based question, okay? Yes, we are... I can't say we're looking for something 100% specific, but you got to make sure it makes sense. So if you're going to put some random thought down, which happens, make sure you can justify it, okay? Don't just go, for example, people need food, okay? Give 2 reasons why there's a continuous demand. People need food. Okay, that's nice. Cause and effect, okay? The population is growing, therefore there's a greater demand for food. Okay, you can't just say the population is growing. You need to qualify what you're saying. All right, very, 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 very important. Okay? Are there questions on what I did now, do you think?
No,
No?
not
No?
what you're busy with now.
Okay, good. So let's quickly start the next question. We won't get through all of it, but I think what we're going to do is I want to show you again before we take a break how these flow diagrams work. I love these flow diagrams. Ammonia, ammonium nitrate, and ammonium sulfate, and this is from the 2010 exam, are 3 important nitrogen-containing fertilizers. The flow diagram shows how these fertilizers are produced. So now I'm not even going to look at the questions. Okay, let's just look at what the flow diagram is telling me. I have air, which produces nitrogen. We've just done this process, okay? That's fractional distillation. So I'm going to write it in here. Fractional distillation. Now, grade 12s, what I'm doing, what I'm doing on the board here and the writing that I'm doing, guys, do this on your exam paper. It's your exam paper. It's your question paper. At the end of the year, you can go home and eat it if you want. Please don't throw its paper. It's not good for you. It has no nutrients, okay? But you could if you really wanted to. Or, as I know some of you can't wait to do, is you go put it on a bonfire with all the rest of your school stuff and go, yes, school's over. No, that would be quite sad because it's your science paper and it's your favorite subject because I'm your favorite teacher. Moving on. Okay, then nitrogen plus hydrogen, that together gives me the Haber process. Okay, and the compound that forms is ammonia. And then from there, I go through the Ozwald process, and the Ozwald process is to form nitric acid. Okay, and then we look at the other side. We've got sulfur contact process, gives me SO3, gives me H2SO4, ammonium sulfate, because over here I've added ammonia and sulfuric acid. Then I added, so that's what this is saying, then I added the ammonia to the nitric acid, and that forms ammonium nitrate, okay? These last 2 don't have names, but it's how we form the ammonium salts, what they said over here. So the ammonia. So the ammonia comes from the Haber process. Okay. We need the nitrate, which comes from the Ozwald process. And the sulfate for the sulfuric acid comes from the contact process. Okay, so we've got all of those. Probably somewhere along the line, I'm going to need to write some equations down, but I can't get that from the flow diagram as it stands, okay? There's no way I can now predict what the questions are going to be, but I understand the flow diagram, which means the questions are going to be a lot easier, okay? And I think, Tebogo, that is a great place to take a little bit of a break.
It sure is.
And then we can carry that on afterwards.
Okay. Before our little break, I want to make a quick announcement of last week's winners, well, the winners of the cashier calculator from last week's shows. A big congratulations to Terry Mudiga and Ntwanano Mazibuko. Congratulations to you two. You've won yourself this amazing cashier calculator, which is one of the important tools that make a student's life easier. I'll see you guys in a few minutes. Welcome back, Matrix. I hope you're all refreshed and have tackled the challenge question. I see there's a lot of answers to the challenge question. There's a lot of C's and a couple of A's, I think about 2. So I'm not sure what the answer is, but because there's a lot of C's, majority rules, I think it's C.
Yeah, majority. Yeah, not so right. Anyway, moving on. I say nothing.
You say nothing.
I say nothing.
Okay, so let's find out what the answer is. Enjoy the rest of your show, guys.
Okay, I'm first going to finish this question. Then I have to make a correction to a mistake I made. Sorry. And then we'll do the challenge questions. I'm going to keep them on tenterhooks and you, because I can. Okay, so let's quickly tackle this question. All right, so the question is, use the information in the flow diagram above and write down the following. Name of process 1. Oh, wait, look at that. Fractional distillation of liquid air. Done. Don't have to worry about it. Oh, look, balanced equation for process 2. Process 2 was the Haber process. Didn't we just do that? Of course we did. I'm hoping you realize all these questions are the same. So here, they want the fact that, no, not 2, I'm lying to you again. So N2 plus 3H2 then gives me 2 NH3. Brilliant. Name or formula of compound X. Compound X we recognized was nitric acid, so you could either write HNO3 or nitric acid, either. Okay, doesn't matter because they said you could write either. Balanced equation for the preparation of the ammonium salt using sulfuric acid and compound Y. So this is why this is so important, because now we knew that we had ammonia plus sulfuric acid, so we know we're going to make ammonium sulfate, which I actually showed you earlier. So ammonia plus sulfuric acid, maybe I shouldn't spit all over the board, gives me, I'm determined to write the ammonium wrong today, so that's 2. And to balance it, I would need a 2 in front of the NH3. Guys, if you really struggle with balancing, rather leave the balancing, make a note of it somewhere in your paper, and then go back to it rather than spending 20 minutes trying to balance an equation, okay? Name or symbol of the primary nutrient in ammonium sulfate. That is nitrogen, okay? Guys, be careful here, please, in that you can't actually write this as N2 because it's not nitrogen gas. The primary nutrient is nitrogen as an element and nitrogen atoms. Okay, so please, 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 please be careful. Do not write nitrogen gas. Do not write N2. Write down one positive impact of fertilizers on humans. Well, it allows food to grow faster, which means humans have food. Bonus, okay? It allows our crops to grow, all of that sort of stuff, makes it easier. And then, of course, and also one of the other things that you can look at for here is things like the production of fertilizers creates jobs, okay, which brings in income for people. The selling of the fertilizers stimulates our economy. But I would go, well, positive impact on fertilizers, it allows for faster food production, which quite frankly I'm quite pleased of, so most days. Okay, then right down to negative impacts of the use of ammonium nitrate as fertilizers on humans. Oh, and once again, it's gone mad. Guys, this is also quite important in that you can't just say a negative impact is eutrophication, because eutrophication has a negative impact on humans and on water life. So if you say eutrophication in water supplies leads to unsuitable drinking water, okay, or eutrophication leads to the death of marine life, therefore less food for humans, stuff like that. Or even things like eutrophication can lead to a syndrome known as blue baby syndrome, okay, where literally babies in the mother's womb don't get enough oxygen. Because they don't get enough oxygen, they are oxygen deprived and they come out blue. All right, sometimes this leads to non-permanent side effects. Sometimes it leads to permanent brain damage and those sort of things because there's not enough oxygen to the brain. Okay, so that's quite dangerous. Other things we've got, if we have too many nitrates in our soil, it actually is bad for our plants, so we can't have too many. Okay, sometimes if we have too many fertilizers, it acidifies our soil, then our food production goes down. So guys, you can't just give one part of it, just like the last question, it's cause and effect. Okay, cause and effect, very, very, very important. So, let's jump in at the challenge question, which I'm suspecting wasn't that much of a challenge because most of you got that it was C, but I did give it away in the middle of the lesson, and well done. I put this in deliberately. Hopefully none of you even thought about well, you did say some gave A.
Yeah.
I'm sorry, that came out wrong. It can't be decomposition. A decomposition reaction is, for example, when I take potassium chlorate, heats it, and becomes potassium chloride and oxygen. It becomes smaller. Oxidation requires the transfer of electrons, and I know it's not oxidation because when we look at the reaction, okay, so we have ammonia plus nitric acid, okay, none of the oxidation numbers aren't going to change. The hydrogen is going to be given away to the ammonia, and like I said before, normally we would get a water, but we can't because there's no H, so we end up with ammonium nitrate, and it's not dehydration because we're not taking water out. Okay, so it can't be dehydration because we're not taking water out. There are questions, eh?
Yes.
Okay, before we get there, I have to make a correction. Okay. And I do apologize, and it's to Sandeli as well because sometimes I am human. Don't tell my learners, okay? I've convinced them I go through a portal in my cupboard. And I think sometimes the grade 9s believe me. It's very sad. Anyway, so if we take SO3 and add it to water. Now, I've gone and told you, and I am incorrect, that it makes sulfuric acid. It doesn't. It does actually make sulfuric acid straight away with SO3. But we don't do this. This reaction is extremely exothermic, okay? Which means that this sulfuric acid that gets formed actually is formed in vapor form. It comes out as a gas, okay? Sulfuric acid is an extremely strong acid. It is very, very corrosive, okay? And because it is so corrosive, if we now have it in gas form, how do we contain it? Okay, now I personally have had an acid burnt by sulfuric acid, and it's not pretty, and it is very, very sore. Okay, like it was the beginning of my career, and it was on my hand, and I still have the scar. Okay, it was very sore, and that was only a small amount. If you get anywhere near vaporized sulfuric acid, you are in serious trouble. Okay, so it's sulfuric acid, but it's extremely dangerous. Sulfuric acid, okay, actually comes when I mix H2O with SO2. That's when I make sulfuric acid, and that is acid rain. Okay, so I do apologize, particularly to Sandelia, okay? It does make sulfuric acid, it's just too dangerous, okay? Which is why we can't put it in that, because it's just too dangerous. Okay, so
Questions.
let's do some questions, and then maybe we'll have time for the last one that I had planned. Yeah.
Okay, your first one from Sigelela Chuma
Yes.
is asking, can you please explain contact process again?
Okay. I'm not. We don't have too much time, but
Okay.
okay. What was her name?
Sigelela.
Sikulele. I can say that, sort of.
Yay.
Okay. Sweet pea, with the contact process, basically, my best advice to you here is actually just learn the four steps, okay? Sulfur plus oxygen gives me SO2. The SO2 is then added to oxygen to give me SO3. The SO3 is then added to H2SO4 to give me H2S2O7. And then that gives, plus water gives me H2SO4. So what does that mean? Watch, I'm going to show you quick. Okay, so sulfur plus oxygen gives me sulfur dioxide. To that, I now add oxygen. That gives me sulfur trioxide. To that, I add H2SO4, which gives me oleum, or pyrosulfuric acid. And then to that, I add water. Let's make that look like water and not H2S. Okay, and that gives me 2H2SO4. That's basically the contact process as more as a flow diagram. Okay, so S plus O2 gives me SO2, SO2 plus O2 gives me SO3, SO3 plus H2SO4 gives me H2SO7, and H2SO7 plus water gives me H2SO4. Learn the process, sweet pea. Okay, that's the best advice I can give you at this. It's not one of those things where you can really well, there is an understanding process, I guess, to it, but this is where you learn all the different parts to it, okay? And you learn, for example, in this reaction, I need vanadium pentoxide as my catalyst. You learn what the temperature must be, you learn what the pressure must be, and those are pretty much the questions they're going to ask you. Application comes in when I take that sulfuric acid and mix it with something else to form the fertilizers. Okay.
Okay, and another quick question. Given Sivande is asking, why does increasing the pressure rather increase the chance of molecules of hydrogen reacting with molecules of nitrogen?
Okay, so we're going back to the Ozwald process. Okay, no, to the Haber process. Okay, this is, I'll do it here. Remember, this is a equilibrium issue. So when we look at the balancing of this, okay, over here I have 4 molecules of the gas, and here I have 2. Now, pressure is defined as the number of collisions per unit area, okay, onto the sides of the container. When I increase the pressure of the container, that means I get more and more collisions. And I like to describe equilibrium as a teenager. Just take it. Never happy, okay? When they're cold, they want to be hot. When they are hot, they want to be cold. When they get told to clean their room, they don't want to clean their room. When they don't get told to clean their room, they will clean their room. Okay? When they get told to do their homework, they don't do their homework. They always do the opposite of what we told them to do, because that's what teenagers are like, okay? You grow out of that sometimes. Okay. So, if I increase the pressure of the system and I make the pressure really, really high, and that means that I now have lots of collisions. This system now goes, we don't like this. We don't like that extra pressure. The only way I can get rid of that extra pressure is to go to a place in the equilibrium where I have less molecules. If I have less particles, there's less collisions, the temperature decreases. Okay? So by increasing the pressure on the system, I make it go to the place where there's less particles. So I make more NH3. It's all about reversing whatever we did to it. Okay?
Okay, and then
Yep.
one last quick question from Lungelo Mjali, and she's asking, what happened to one of the hydrogens in the formation of ammonium sulfate?
It hasn't gone, sweetie. If we go back to which I don't even know. Okay, I'll just write it here. Okay. it actually hasn't disappeared. So there's ammonia, there's this sulfuric acid, which I'm about to write with 4 hydrogens in it, H2SO4, and now you were concerned because when I wrote this, I said NH4 plus and SO4 minus, and then we were like, oh, where did it all go? Okay, don't stress about it, because what actually happens here, and I didn't balance the equation, this was the difference, is yes, when that hydrogen goes along, this forms NH4 plus. Okay? This, remember, we're always going to go to complete ionization, so we're doing a bit of acid bases here. This becomes SO4 2 minus. Now, in order for these two to bond together, I actually need 2 ammoniums, okay? Which means I need 2 ammonia molecules. So when we write this as a balanced equation, I haven't actually lost the hydrogen, okay? I just didn't write it as a balanced equation because remember, I've got to make sure it's balanced when I put it together. And we always assume that when it comes to this, that the sulfuric acid will give away both of its hydrogens for this, okay, to make the ammonium sulfate, okay? And I'm hoping that answered that question.
Yeah, I think so.
Yeah.
And then
Okay. And we've run out of time.
Yes, we have. But you'll be happy to hear this, though.
Yes.
Shizzy Shadung says, you have my vote.
Thank you.
Hashtag smiles. And then Lungelo again says, lol, Tracy, the board is on steroids. Every Monday, it's not you, my dear. But you still got my vote. Definitely enjoy your show.
Oh, you guys are amazing, guys. Have a good week and enter all the competitions.
Yes.
Win fun stuff.
Do that.
Yeah.
And thank you so much for tuning in. I trust that you have a very valuable learning experience this hour. And do not forget to tune in, well, stay tuned in. Immediately after this is going to be an insert to help you with learning how to drive skills and advice and what else?
Ellie docking.
Alley docking. That's the focus
Yeah.
on today's insert. So be sure to tune in, and I'm sure you've reached that time of, that age where you actually should learn how to drive. Until next time, guys. See you. Bye.